Well, my next job is to add up these areas. And I've already prepared that by finding out what the base and the height is. So the total area, or the sum of the areas, let's say, of these rectangles is, well, the first one is b over n times b over n squared. The second one is 2b over n, I'm sorry, is b over n times 2b over n squared. And it just keeps on going. And the last one is b over n times nb over n squared. So it's very important to figure out what the general formula is. And here we have a base, and here we have a height, and here we have the same kind of base, but we have a new height, and so forth. And the pattern is that the coefficient here is 1, then 2, then 3, all the way up to n. The rectangles are getting taller and taller, and this one, the last one, is the biggest. Okay, this is a very complicated gadget. And the first thing I want to do is simplify it, and then I'm actually going to evaluate it. Well, but actually, I'm not going to evaluate it exactly. I'm just going to evaluate the limit. It turns out limits are always easier. The point about calculus here is that these rectangles are hard, but the limiting value is an easy value. So what we're heading for is the simple formula as opposed to the complicated one. All right, so the first thing I'm going to do is factor out all of these b over n factors. There's a b over n here, and there's a b over n squared. So all told, we have a b over n, the quantity cubed, as a common factor. And then the first term is 1, and the second term, what's left over, is 2 squared. And then the third term would be 3 squared, although I haven't written it. And the last term, there's an extra factor of n squared in the numerator.